on this computer. Okay. I started recording already. So basically for this homework problem, this particular homework problem, we have to solve for FAB. In order to solve for FAB, we have to solve for member EF first. Yeah. But unfortunately, there we have 5 unknowns, so we cannot solve it directly. That's why we can try to solve 2 of those unknowns from this particular free body diagram. So using those systems. So this is the one that I try to draw right now. Okay, I think maybe I will miss it. Okay, so but roughly it's like this. Okay, we have 1800 Newton here, and then we have at point E, yeah, we have EY and EX. Okay, EY and EX. Okay, because EY and EX, I assume it that way. Here is supposed to be the opposite. Going down, EY. EX is supposed to be going to the left. Okay, EY and EX. And beside that, at point D, we have force from 2 force member DC. So we have FDC here. Okay, in this case, okay, in this particular free body diagram, we have 3 unknowns. From those 3 unknowns, we will be able to find EX, EY, and FDC. Okay, and after you solve for that, you can go to the second free body diagram, this one. EY and EX there is already solved. Okay, because of that, then you can solve for this particular free body diagram, because now we only have 3 unknowns: Fy, Fx, and Fab. So it's solvable. But as what William told us just now, whatever way you do to solve the problem, okay, using sigma Fx, sigma Fy, sigma moment like that, the result is supposed to be the same. Okay, it shouldn't affect the result. So if you get different results from 2 different ways, I suggest you to check again. Okay, most likely one of which is you made a mistake. You make a calculation mistake in one of which. Okay. So this is our first homework. It's supposed to be no problem here. And this is our second homework. Okay. I believe just now Rafi asked for this, right? Determine the cutting force F applied, okay, by the plate DE to the bar G in terms of force P, okay, applied to the handle of the heavy-duty cutter. Assume that the cutting force F is perpendicular to the lower edge of the blade DE. Okay, perpendicular to the lower edge. Okay, perpendicular to the lower edge of the blade DE. Okay, so what is the question here? What's your question here, Rafi?
We have to find the force F that's touching the object.
That's the question, yes. We have to find the force there. And based on the problem here, the statement in the problem, okay, the force will be perpendicular to the lower edge of the blade. So if the lower edge of the blade is like this, so the force will be perpendicular like that. Okay, Rafi? So which part of it that you have a problem here?
I'm still a bit confused for the curved beam that's BE, sir.
Okay. What do you think about BE?
I believe it's supposed to be a double, two force member, right, sir?
Yes, correct. It's 2 force member. So as I told you before, okay, 2 force member, the shape of the 2 force member can be anything. So as long as you have 1 member, whatever the shape is, okay, and it has pin joint at both ends, and the load it comes from only the pin joints, okay, and there is no friction there, no moment at the end as well, okay, it will be two force member. And how can we represent the force there? Okay, the force there is supposed to be the straight line between those two joints. So if it's under tension, it's supposed to be like this. If it's under compression, it's supposed to be the other way around. Rafi, do you get it, Rafi?
Also, whatever kind of shape it is, so whatever kind of curved shape it is, sir, the FBE should just be a straight line, right, sir? There's no
yes, correct.
angle.
Yes, correct. Okay, the same thing applies for this kind of shape as well. Sometimes two force member can be in this kind of shape. Okay, you have two joints, okay, at both ends, and the force only comes from the both joints, and there is no friction at both ends. So the force is supposed to be in the straight line. If it's under tension, it's supposed to be like this. If it's under compression, it's supposed to be the other way around. Like this. You get it, Rafi? Hello, Rafi? You get it? Rafi is gone. Hello?
Hello, sir. Sorry,
yep.
I got cut off. Yeah.
Yeah, okay. So it means that you get it, right? And if we take a look at this particular problem, in my opinion, the problem, the most problematic things about this is the dimension. Okay, apart from that, it's supposed to be okay. And if we do it in sequence, what you're supposed to solve first is this particular member ABC. Okay, from ABC, you can see that ABC there. In ABC, you have a force P there. Beside that, at point at A, there is a pin joint, so there will be AX and AY there. And at B, because of PE is two force member, so it will be FBE there. Yes, somewhat like this. So there is a P here, and there is a AX, AY, and beside that there is FBE there. Okay, FBE there is straight line from point B to point E. Okay, and because P is known, so we have AY, AX, and FBE. We have three unknowns. We can solve this particular free body diagram. Okay, the main thing that you have to get from this particular free body diagram is FBE. So you can solve it using sigma moment at A. Okay, sigma moment at A to solve for FBE. Okay, after you get FBE, then you have to solve for the blade DE. Okay, the blade DE. Yeah, for the blade DE is known to two force member. I can draw it here. Okay, so at E there is supposed to be a force from two force member BE, action and reaction with the previous one. And you already know the value from the previous one. Okay, and beside that, at point D, there is a pin joint, dx and dy. Okay, and at the lower edge, there is a contact force between the plate with the things that we cut there. Okay, and it's supposed to be perpendicular to the lower edge. Okay, so I name it as cutting force F, like that. Okay, yes, of course, you still need to you need to calculate for the angle of the F here, but all the information are there. Okay, D is at the same height. D is here. We know the height of that, and the things G there. The height is 5 millimeter difference there. We have a 5 millimeter difference in height there, and then the horizontal distance there is 48 millimeters. So we will know about the angle there from those information. Okay. So from this we have the horizontal distance and we have the vertical distance. So we will know about the triangle there, and because of that we can see the perpendicular angle there. Okay, Rafiq, it's supposed to be no problem, right, Rafiq?
Yes, sir. I think my mistake was I put cos 14, so my calculation was weird in that sense.
So,
thank you,
so
sir.
this one is not as a 2 force member, you mean?
No, I accidentally put cos 14 there, sir. So
Okay.
I thought it was angled. Yeah.
Hey, wait a minute. Maybe it's a 14. Sorry. Wait. 14 degrees there. Yeah, most likely it is. So you can use that one as well, actually.
Okay, sir.
Yeah. So it's supposed to be okay. Yeah, there is a 14 degrees there. I didn't see that. Okay, yeah. The angle there is supposed to be 14 degrees and it's supposed to be perpendicular to that. Okay. So number 2 is not supposed to be a problem. Number 3 is quite straightforward as well. For number 3, you have to see here that DC is 2 force member. Okay. And the spring FE, you can assume it as 2 force member as well. Okay. The elements of the suspension system for the front wheel drive car are shown in the figure. Determine the magnitude of the force supported by the spring here, this one. If the force exerted, the force F exerted to the tire was 3,600 Newton. Okay, so the force here is 3,600. So the first thing that you're supposed to analyze is this particular free body diagram. Okay, that one is quite simple. So we can just draw that particular free body diagram. Okay, we can just draw this particular free body diagram, and we have a 3,600 Newton there, and beside that at C there, because CD is 2 force member, so you have to put FCD like that, and at B, because AB is not 2 force member, so at B there will be BY and BX. Okay, from this particular free body diagram, actually I'm drawing this. Okay, you will be able to find out BX, BY, and FCD. Okay, BX, BY, and FCD. And then after you find out the BX, BY, the next thing that you're supposed to solve is this one, the bottom one. Okay, AEB, like this. Okay, you have BX, BY there from the previous calculation, which is known. Okay, and then we have AX, AY. Okay, at point A, and FEF there. Okay, FEF, because EF we can assume it as a 2 force member, and FEF is the one that we have to find out. BX, BY is known from the previous calculation. So from this particular free body diagram, we have 3 unknowns. We have 3 equations, so we can solve it. So number 3 is quite straightforward. Okay, any question for number 3? No? Okay. In that case, I will continue. Number 4. Just now, who asked for number 4?
Me, sir. Irshad.
Irshad. Okay, Irshad. So this one is from the past exam problem as well. It's about the car hoist. Okay. So the one in question is the total load. The total load on the platform from both rear wheels is 6 kilonewton. So the load from the rear wheels is 6 kilonewton. Okay. The member BCD is right angle bell crank. Okay. Which means the angle BCD is 90 degrees. This one, the angle here is 90 degrees. And is attached to the platform by pin joint at C. Okay, the masses of the platform, hydraulic cylinder, AB and crank BCD can be assumed negligible. Okay, the pin joint O, A, B, and C, and also roller D can be assumed to be frictionless. The one that in question is this one, the force in the hydraulic cylinder. Okay, which part of it that confused you, Irshad?
I'm not quite sure how to start the problem.
Okay.
Like from which point?
In this case, for number 3, number 1, 2, 3, you have no problem with that, right, Irshad?
It was okay, I think.
Okay. So for this one, the one in question is AB. Okay, the force AB there, and you know, right? AB here because it's cylinder as well, and it has only pin joint at both ends. It's supposed to be 2 force member, right? Irshad?
Yes, I knew that.
Yeah, AB is 2 force member. Then we have a beam BCD 90 degrees. Okay, and there is a roller here, frictionless roller. So there is supposed to be a normal force there. Okay, and then there is a pin at C. Wait a minute. There is pin at C, and there is a load here, and there is a hinge at O. Okay, so actually, we can start from the one that is the nearest to the load known load. Okay, or you can start from the one in question, then try to trace in order to finish that what variables that we have to solve first. Okay, in this case, I will try using the second method. Okay, I will try to trace it backwards. The one that we need is AB. Okay, in order to solve AB, I have to solve for BCD, right? Because AB is connected to BCD, or I can solve ACO as well, because A is connected to that particular structure as well. Okay, but I will try using the BCD. Okay, from BCD here, I know that there is a FAB there. Okay, I assume the FAB is compression. FAB. Then beside that, what other forces that we have here? Yes, yeah.
Is BY still there?
DY, you mean?
Yeah.
Okay, DY. Yeah, because of roller. What else?
Does BY not exist? Because it says it's a pin joint.
Because remember, AB is a 2 force member, right?
Okay, sir.
That's the main thing. Why I told you guys to try to identify the 2 force member, because when we identify that, a particular member as two force member, then we can replace the force at both joints of that particular member to be just a straight force at the same line as the two force member. Do you get it, Irsyad?
Yes, I understand now.
Yeah. So just now we did the same here. Right? DC is two force member. That's why I put FCD here instead of CX and CY, right? And beside that, this one as well, we know that FE is two force member. That's why I put FEF here instead of EX and EY. Okay. This one as well. Just now, Rafi has a problem with this. BE is two force member, although it's slightly curving, right? But BE is two force member. That's why instead of putting it as EX and EY there at B, okay, I put it as FBE. Do you get it, Irsyad? So that's the first thing that you can do. Okay, simplify the problem by finding out the two force member. Okay, Irsyad?
Yes, sir.
Okay, this one is FBE. We have TY because of rollout. And at C, what we have at C?
CX and CY.
Yeah, because it's a CY and CX. Yeah, because we that one is just a pin, right? And BCD is non two force member. Okay, and from this, okay, from this one we have four unknowns. The one that we want to find out is FAB, DY, CX, CY. We don't want that, but it's an unknown, so we cannot solve this. Okay, but we have draw the free body diagram here. As long as we can solve for one of which, right, one of the unknowns here, we will be able to solve for the problem. Correct, right? Okay, Irsyad?
Yes, I think so.
Because if we can solve for one of those, now our unknowns will become only 3. Now let's take a look at the whole system. We can use that as our free body diagram as well. Irsyad. If you take a look at the whole system, right? Okay, our free body diagram will become like this. It includes everything, okay? It includes everything. So I draw it like this. Okay, I draw it like this. It includes everything. Okay, and if we take a look at the whole free body diagram, this one. Okay, what forces, what external forces that we have there, Irsyad?
The load from the tire and
The
the
load from the tire, correct? It's supposed to be 6 kilonewton.
DY.
Okay, this one is 6 kilonewton. 6 kilonewton. And then dy, correct? What else?
And OX, OY.
Correct. OX and OY. From this particular free body diagram, how many unknowns do we have?
3.
Only 3 unknowns, correct. Only 3 unknowns. Dx, OX, OY, dy. Okay, can we solve this, Irsyad?
Yes, because
we
the
can.
number of
Basically, what you need to solve here is just dy actually, because if we solve dy, okay, we can put dy here, and we can solve for FAB. Correct, right?
Yes.
Yeah. So for this one, you just need to use one equation: sigma moment at O equal to 0 to solve for dy. Then you will be able to find dy. After you find dy, use it in the second free body diagram. Okay, And because the one in question is just the hydraulic force FAB, you can just use one equation as well, sigma moment at C equal to 0. Using that, you will be able to find FAB. Do you get it, Irsyad?
Yes, I think I understand now.
Good.
Thank you, sir.
Yep. So this is our fourth problem. And then let's go for this one for number 5. Do you have any questions here? Basically, here we have several free body diagram. Several two force member. EF is two force member. CF is two force member. Then BF is a two force member. So we can simplify the case using that. Okay, and FH here, because it's spring as well, is two force member. So we have a lot of two force member here. Okay, but because there is no question on this particular problem, then I assume that you understand about this. Okay, and actually that's all about our discussion in the frame and machine. Okay. Although we are lacking in comparison with the other classes, because we are trying to catching up as we are losing 2 hours more than the others. I think I will try to cope with it with the normal, our normal classes first. But later, if it's near to the second exam and we still catching up, then I will use the, I will try to hold the additional class at a particular time. So we won't do it in 1 or 2 weeks, but we will wait until near to the second exam. Okay. About frame and machine. Anyone here want to ask question? I should remind you, okay, again, okay, in the frame and machine, try to find the two force member first to simplify the problem. Then after that, the non-two force member or the whole problem, okay, you can try to solve it one by one. For example, this one, we solve for the BC, okay, this particular system, because it's non-two force member, free body diagram of that one, and then the member AEB, because it's non-two force member, one by one, okay, to solve for the FEF, okay. But for this one, number 4, okay, instead of solving the non-two force member one by one, what we do here is solving the whole free body diagram, okay. So the whole free body diagram like this to solve for all the external forces. Then we solve for the non-two force member there. Okay, so basically what you're supposed to do in order to solve for frame and machine problem is by trying to take a look and try to map how you can solve the problem in question. Okay, not necessarily you always have to use all the non-two force member. Sometimes we can solve it just by using 1 or 2 non-two force member free body diagram, or sometimes we can use the whole free body diagram to solve for the unknowns that we need, like that. Okay, for example, it's like this one. We know that by solving one of the unknowns, we can solve for the problem using this particular free body diagram. Then we use the whole free body diagram to solve for dy, and we bring dy here to solve for FAB. That's the example. Okay, so when you try to solve for statics problem, all the statics problem, including this, try to plan the way to get to the main problem. How to solve the main problem, try to plan. Okay, by solving this, I will get this. By solving this, I will get this. And if I get all of those, I will be able to solve for the last free body diagram to solve for the main problem. Okay. Any question about the frame and machine? Before I continue with the next topic.
Misi Pak, tadi saya agak disconnect. Boleh minta tolong jelasin yang nomor 5 nggak? Saya masih agak bingung.
Oh, nomor 5, oke. Nomor 5 ini tidak ada yang bertanya tadi, makanya saya tidak menjelaskan segitu banyak. Ya, ini permasalahan di sini itu adalah mulai dengan simplifikasi. Ya. Tadi yang nanya siapa?
Derin.
Hah? Siapa?
Derin.
Derin, oke Derin. Oke Derin. Selalu mulai dengan simplifikasi ya. Simplifikasi terkait dengan batang dua gaya yang kita miliki di sini. Nah, batang dua gaya yang kita miliki di sini apa saja?
BF, FH, EH, dan CF.
BF, ya, EF, CF, FH ya. Kita punya, kita punya 4 free body diagram, 4 batang dua gaya. Kemudian yang diketahui juga adalah poin B dan juga poin H itu ditempelkan di lengannya, tertempel di lengannya, ya. B dan H ini tertempel di lengan. Oke, lalu pertanyaannya, sorry. Oke, beratnya 30 Newton. Lalu gripnya adalah 10 Newton. Oke. Determine the force supported by the pneumatic cylinder. Ini ya berarti ya, PF. And the spring. Okay. And the spring. Assume that that while holding the bag of groceries, the arm and hand have the geometry of. Nah, kalau menurut kamu, Derin, kita mulai dari mana nih, Derin? Dari yang ditanyakan apa ya, Derin?
Yang ditanyanya itu gaya di BF.
FBF ini ya?
Iya.
FBF itu ditanyakan yang satu. Lalu yang kedua adalah FFH ya? Ya, itu adalah yang kedua. Oke, jadi kita punya 2 hal yang harus diketahui. Yang menurut kamu lebih gampang untuk diselesaikan terlebih dahulu ya, Pak?
Mungkin BF.
BF, yakin kamu BF? BF itu gampang didapatin ya?
Kalau aku agak susah lihat yang sistem yang ini, Pak.
Coba lihat keseluruhan sistemnya. Kalau kita melihat keseluruhan sistem itu, keseluruhannya kita lihat ya. Kalau keseluruhannya kita lihat, free body diagram ini kita lihat keseluruhan. Oke, ini kalau boleh jujur ya, makanya ini kenapa kok saya agak sedikit bingung tidak ada pertanyaan untuk nomor 5. Ini waktu ujian saya itu beberapa tahun yang lalu, yang menjawab benar itu mungkin cuma 1-2 orang. Seangkatan. Oke, seangkatan itu yang jawab benar malah cuma 1-2 orang. Makanya kenapa saya bingung kok tidak ada yang menanyakan tentang ini terkait dengan ini. Ini soalnya memang susah. Oke. Nah, coba lihat keseluruhannya, Derin. Free body diagram keseluruhan. Anggap FFH itu sebagai gaya luar. Oke. Dari keseluruhan free body diagram tersebut, kita bisa menyelesaikan si FFH langsung. Betul tidak?
Iya bisa.
Karena kan diketahui dia nempel di lengan itu di H dan B ya. Jadi kalau misalkan kita melihat si prosthetic arm-nya itu secara keseluruhan, gambar saya agak jelek ya. kalau kita melihat prosthetic arm-nya secara keseluruhan seperti ini, oke, di situ akan ada gaya dari batang 2 gaya FFH. Apalagi ada di sana. Di titik B itu kan pin ya. Pin, sehingga akan ada muncul BY, BX, betul ya?
Iya.
Terus akan ada gaya berat ya dari si groceries itu 30 Newton ke bawah. Oke, gaya tekan yang saling menghilangkan karena A menekan ke D menekan ke A, betul nggak? Ya, jadi ini gaya diagram benda bebasnya yang keseluruhan. Bisa diselesaikan nggak nih?
Bisa.
Ya, kita bisa dapat BX, BY, FFH kan ya. Jadi FFH paling tidak dengan menyelesaikan ini kamu dapat separuh nilai nih. Oke? Jadi kamu sudah bisa dapat ya mana tadi pertanyaan? Pada spring ya. Oke?
Oke.
Nah, selanjutnya pertanyaan selanjutnya ya. Untuk mendapatkan ini FFH berarti udah clear ya. Kita mendapatkan bagaimana? Nah, sekarang BF, FBF. Bagaimana cara mendapatkan si FBF itu?
Join method.
Join method di F ya? Bisa ya harusnya?
Mungkin.
Ya, join method di F. Tetapi dari situ yang baru kita ketahui baru FFH saja. FFH. Selain itu FEF sama FCF kita belum tahu ya. FCF, FEF, FCF, lalu FBF. Semuanya saya anggap tarik. Tapi ini belum bisa diselesaikan kan? Betul ya?
Iya, belum.
Tetapi kalau salah satu dari FEF dan FCF itu kita bisa ketahui, ini harusnya bisa diselesaikan kan ya? Karena kita punya dua persamaan kalau keseimbangan titik itu. Sigma Fx sama dengan 0, sigma Fy sama dengan 0. Jadi kita bisa menyelesaikan dua unknowns kan? Betul tidak?
Betul.
Ya, jadi FFH sudah diketahui, tetapi ada 3 unknowns, kita belum bisa menyelesaikan karena kita cuma bisa menyelesaikan 2 unknowns. Nah, targetnya sekarang untuk bisa menyelesaikan kasus ini, kita bisa terlebih dahulu menyelesaikan FEF atau FCF terlebih dahulu, betul nggak?
Iya.
Oke, nah sekarang kita coba lihat. Kamu mau yang diagram benda bebas yang mana nih?
EF aja.
EF, oke, kita coba selesaikan yang EF. EF itu tersambung ke DBE, bukan?
Iya.
Oke, nah sekarang kita coba lihat diagram benda bebas dari si DBE. Ya, kira-kira seperti ini ya, walaupun gambar saya agak jelek. Oke, di situ ada EF ya, tarik. Lalu ada apa lagi?
Grade-nya 10 Newton.
Ada gaya berat ya, karena cenderungnya gaya berat itu kan ketanahannya munculnya di bagian bawah kan ya, bukan atas kan?
Iya.
Oke, berarti ada 30 Newton. Lalu ada juga gaya tekan ya. Oke, gaya tekan dari A ke D ya. Betul nggak?
Iya.
Kalau A memberikan gaya tekan ke D, itu berarti arahnya ke bawah atau ke atas?
Ke bawah.
Ke bawah juga 10 Newton. Seperti ini ya. Terus selain itu ada apa lagi?
BXBY.
BXBY. Cuman, nah ini yang akan repotnya itu cukup repotnya di sini. BXBY di sini itu tidak sama dengan BXBY yang ada di sini. Karena BXBY yang ada di sana itu terjadi pada pin. Ya, pin si arm-nya. Jadi pin yang nempel di lengannya seperti itu. Sedangkan BXBY yang ada di sini, yang ada di kanan ini adalah BXBY yang terjadi pada si batang DBE saja. Jadi agak sedikit berbeda di sana. Ya, Karena ini koneksinya, kalau kalian bisa lihat ya, di B itu koneksi dari batang apa namanya? Batang DBE, oke, batang DBE, kemudian batang ABC dan batang BF, betul ya? Ya. Jadi misalkan saya gambar saja ini BXB, tapi mungkin saya tuliskan BX aksen dan BY aksen ya. BX aksen, sorry, BY aksen, BX aksen. Nah, BX aksen dan BY aksen ini merepresentasikan reaksi-reaksi, merepresentasikan gaya-gaya yang terjadi pada titik B akibat A, B, C, dan BF. Kebayang ya?
Iya.
Ya. Cuman kita nggak perlu nilai itu juga. Jadi yang kita perlukan di sini itu kan sebenarnya cuma salah satu doang kan? FEF doang kan? Oke? Bisa nggak kita dapat FEF doang tanpa menyelesaikan BXB? Karena BXBY di sana, BX aksen BY aksen di sana itu sangat-sangat complicated.
Bisa pakai momen
Bisa.
DB.
Sigma momen di B. Kita bisa dari sigma momen di B, kita bisa mendapatkan FEF. Nah, setelah kita dapat FEF ini, caranya gimana? Bawa ke sini ya. Betul ya? Bawa ke sana, kita bisa menyelesaikan FBF di sana. Oke?
Oke.
Seperti itu. Karena kalau kita menyelesaikan FBF di sisi kiri, itu jadi sangat-sangat complicated. FBF-nya ya, FBF-nya akan mengenai batang DBE, tetapi ada persen FBF yang akan dihandle oleh batang DBE, ada persen FBF yang akan dihandle oleh batang ABC, ada persen FBF yang akan langsung ke si armnya. Kebayang ya?
Kebayang.
Ya, gitu. Makanya kita menyelesaikan FBF-nya dari yang sisi kanan ini. Ini soal yang sangat-sangat susah. Waktu itu diskusi di antara dosennya pun juga agak-agak panjang, tetapi ini bisa diselesaikan. Seperti itu. Ya.
Oke. Masih, Pak.
Yep. Apakah ada pertanyaan terkait ini? Ini kita baru 1 jam. Oke. Nah, satu lagi. Saya ini 2 minggu terakhir itu terganggu oleh sakit pinggang. Jadi kuliah itu tidak akan bisa lama-lama continuous. Setelah ini kita akan lanjutkan ke gaya dalam dan juga gaya terdistribusi. Tetapi sebelumnya kita istirahat 5 menit ya. Mungkin 5 menit lebih dikit, nggak ada masalah. Kita mulai lagi, oke? Kita mulai lagi kelasnya di jam 11:05 ya. Kita mulai lagi kelasnya di jam 11:05. Ini saya pause dulu, recordingnya saya stop dulu supaya nanti kita punya 2 recording yang terpisah untuk materi yang sebelumnya dan materi yang baru. Seperti itu ya. Jadi kita istirahat dulu, mulai lagi jam 11:05. Oke? We will take a break for a while, and we will start again at 11:05. Okay? See you again in 11:05. You don't have to go out from the Zoom